Right, now we'll look at the factors affecting the value of lattice energy. So the two main factors that you have to know about are ionic charge and ionic radius. Let's take an example of NaCl, and let's take an example of MgCl2. Sodium has a charge of positive 1, chlorine is negative 1, and magnesium is positive 2, and this one is negative 1. So the main difference between these two in terms of the charges is that this one is twice the charge of sodium. Now the attraction between these two will be much more than the attraction between sodium and chlorine. So what we will see is that the lattice energy for sodium chloride will be less than the one for magnesium chloride. So this one's lattice energy will be more exothermic than compared to sodium chloride. So remember we said that initially the more exothermic the lattice energy is, the more stronger the bond is. And you can see that positive 2 and negative 1 form a stronger attraction than positive 1 and negative 1, and that's why the lattice energy is more exothermic. Now, when we talk about the ionic radius, let's take an example of NaCl as usual, and let's take potassium chloride. Now, we know that sodium is smaller than potassium, right? Um, but both of them have the same charge. This is positive 1, negative 1, positive 1, negative 1. The only difference between these two is that potassium is larger than sodium. Now, what happens is when you have a smaller ion, such as NaCl, let's take this one as Na, and let's take this one as Cl. When you have a smaller ion, the charge of positive 1 is concentrated in this specific area. But then when you have a large ion, let's say potassium and chlorine with the same thing, this charge of positive 1 is spread around a bigger area than this one, right? This charge of positive 1 is spread around a smaller area, but this one is spread around a bigger area. So this is called charge density. So the charge density for potassium is more than, the charge density for sodium is more than that of potassium. Why is it more? Because the density is how much concentrated the charge is. Here, the charge is concentrated in a smaller area, so the charge density is more than this one. If you have a bigger charge density, then the bond is more exothermic. So here we will have a greater lattice energy than for potassium chloride. So potassium chloride has a lower lattice energy than sodium chloride because it has a bigger ion, which leads to lower charge density. And so there is less attraction between the positive ion and the negative ion. Right, now let's go to another important concept, which is called ion polarization. Now, what is ion polarization? Before, if you remember, when we talk about ionic compounds, how they exist is they exist in a lattice structure, right? They have an ionic lattice. For example, as always, let's take NaCl. NaCl has Na positive ions and chlorine minus ions, right? Arranged in a lattice. This is very bad drawing, but you get the point. That they're all arranged in a lattice like this. Right? Now, sometimes what happens is that this positive cation can actually attract the electrons in this anion. So the ones within this anion, they can be attracted. And thus, the bonding is not very symmetrical. It can become a shape something like this. So for example, if initially it was like just a normal circle like this, but because of the ability to pull this guy, the positive guy is pulling the negative guy so much that it's becoming this weird shape over here. So the anion is said to be distorted, right? So this is called ion polarization, and the ability of the cation to polarize the anion is called the polarizing power of the cation, right? So the ability of the positive guy to pull this anion to it. It's called the polarizing power of the cation. Okay, now the reason why we are learning about ion polarization is because it does one very important thing, which is it determines the thermal stability of an ionic compound. So how stable it is. Remember in AS level we talked about thermal stability, which is basically how stable it is to being decomposed. For example, if something decomposes at 200 degrees centigrade and something at 300 degrees centigrade, this is more thermally stable because it takes more energy to break it down rather than the one of 200 degrees centigrade. So now here we see that the smaller the charge density of the cation, the more thermally stable the ionic compound will be. This is because the lower the charge density, the lower the extent to which the anion is polarized, and hence the stronger the bonds. Let's draw it to explain what this means. For example, let's take, I'm not going to say NaCl this time. Let's say we take Mg, MgCl2, right? So we have this compound over here, and let's take something which is lower than Mg, which is, let's say calcium, CaCl2. Now, magnesium is smaller than calcium, right? So you have magnesium over here, and this is our normal chlorine, and you have calcium over here, and this is our normal chlorine. Again, this is similar to the diagram above, the one that we did before this. Now, both of them have a positive 2 charge, right? Positive 2, positive 2. But if you recall from what we said earlier, this one, the charge is spread more, so it has a lower charge density. This one has a higher charge density. And then it has one side effect to it. Because this one is pulling it more, it's becoming distorted. Okay, so if something is distorted, it's not really stable. It doesn't have a proper stability. So what happens is that the thermal stability for magnesium chloride is actually less than that of calcium chloride. Like the way I like to remember this is that if two things are almost the same size, you see this one is small and this one is big, so they are kind of not stable. But this one is big and this one is big, so they are stable. Because when you distort something, it doesn't like the distortion. It wants to break away from the distortion, right? So magnesium chloride is more distorted, so it wants to break away from it. So it needs less energy to heat magnesium chloride than it takes to heat calcium chloride. So that's why we see that as you go down the group, so you have magnesium, you have calcium, and etc. As you go down the group, then the thermal stability increases. So thermal stability increases. Why does it increase? Because the ion polarization is less as you go down the group. And why is the ion polarization less? Because the charge density is less, and hence they are more thermally stable.